Hello, this is Shakil Ahmed. In today's tutorial, we will learn about using apply function in R that is required when we are dealing with data with vectors, matrices, and three-dimensional arrays. And we need to perform specific operations by row, by column, or by different objects in an array. Then we use apply function, and we have other type of advanced functions with lapply, rapply, vapply, tapply, and all such related functions. If you want to, if you are interested in doing high level programming in R, you must know the basics about these functions. Basically, this is just equivalent to performing some summation on with certain subscripts when we are doing mathematics. For example, we have a data with columns and rows, and we need to sum by column or by row or both by column and row, and we have different objects of different length, and we need to apply a function on all the objects. Then we need to apply the apply function. So let's start with a two-dimensional matrix. I have created a matrix A, and that is a sequence of number from 1 to 16 with 4 by 4. That is just 1 to 16. We have elements, and we can see this is a matrix A with these rows and columns. And we want to we need just minimum of each row. Then we use apply function for the matrix A, and 1 it means we are doing by rows. If you type 2, it will perform the a function by column. So we are just finding minimum of each row. So let's see, the minimum of first row is 1, second row is 2, third row is 3, and fourth row is 4. So you can just see 1, 2, 3, 4. These are the minimum values in each row. And you can see the maximum value of each row. You can just find these are the maximum values in each row. These are the maximum values. And you can find mean of each row. Uh, it means you can apply any function which you can apply on a vector. Basically, we are treating uh, one by one every rows one by one as the individual vectors and apply certain functions. First, we find the minimum, and then we found the means, and we found the maximums by row. And you can do the same thing by column, as I am just finding the variance of each column by column basically. So these are the variances for by column, as the differences are same, we are getting same variances for each column. And then you can we can uh, take an example of three-dimensional array. Three-dimensional means we have uh, two matrices. First, we have by row, and then we have by column, and the third dimension is by object or by array. So you can see this is sequence of 32 numbers, and we have three rows, three columns. It means we have 3 by 3 a matrix, and there are two objects. So it should be 9. Many elements we have? Just see. P consists of two matrices. It should consist of two matrices. And we have 18 elements. 1, 4, 7, 2, 5, 9. And although you can just write sequence 1 to 9 as you have 1 to 18 as we have written here. So these are two elements in this array, the first matrix and the second matrix. So whenever you're talking about one, this is the basically the arrangement. This the first the element before first comma is the row, and the in this position we have columns, and in this position we have uh, the array. For example, if I name it as it is already named as B, so you can how you can find B, and then how you can get the element in B. For example, 1, 2, and 3. It means I should be 2, sorry, and it should I am setting it as 1. It means I am just selecting this value. This should be 10. Let's see. This should be 10. Means I am selecting a first row and first column and the second element. So you can just perform any type of task with respect to rows, with respect to columns, and with respect to object. If you apply sum with respect to object, then you will get only one single matrix to 3 by 3. And if you apply sum by columns, you will get, you are summing these and these basically, so you will get three values here and three values here. And if you apply sum by row, you will get, for example, one value here, one value here, one value here, and three values here, so you will get six values. So you can perform any type of operation. For example, I am applying sum on row, so I will get sum of this, sum of this, sum of this, three values here and three values here. I will get six values. Let's see. It's giving only three values, as basically it's summing all the values, and then uh, basically we are applying sum on other two things. We are getting just a result by rows, first row, second row, and third row. For example, if you set your result to, for example, two, one or two here for the third dimension, then, for example, we are just summing with respect to, we will do later. We are just summing by column and the object by third dimension by the array. So we will get sum by row. And if you write C1 to 1 and 2, it means you will get a matrix. You are applying sum on 1 and 2, basically on third dimension only. So you can see now this is the sum of these two values. You can see 1 and 10, then 2 and 11, and then 3 and 12. 3 and 12 we have 15. So we are applying sum only by the third dimension. Means we have a value with b, I, j, k. We are applying sum by k. Here we are applying sum by j and k not on I. And then finally, we can find a list, for example, that is the L object. Alpha, basically, we have a list, and what is a list? A list consists of basically different objects in a type of array. For example, we have an array and we have first element a single value, and second element we have a vector, and third element we have a matrix. For example, we can have any type of object in a list. We can have a data frame, we can have a matrix, we can have a vector, any type of thing. So I'm just creating a list of X that consists of three objects A, B, and C. When we talk about a list, we have different objects, and that may be any kind of object. So this is a scalar, and this is a matrix, and this is another matrix. So another vector. Sorry. We have two vectors, and these are of different lengths. So we can see the list, and it consists of three objects. The first is 1, the second is 1, 2, 3, and the third is 10, 2, and data vector. And for example, if I give, this is X, you can, if you want to call any object from the list, you can see, you can just write a dollar sign and you can see the value. And I want to see the 10th value of the vector C, that is 19, right? The 10th value, 1, 2, 3, 4, and 10. So if I want to subset, for example, 10 to 20, just find the 20 value, 10 values, 11 values almost, right? So you can apply the lapply function that will apply on the object, and it means uh, this will apply to every object of the same list. We have three objects and we are finding the length of each object. For example, what is the length of each object? Then we apply the function fun command and the length. So this will return you the length of every object. This is length of 1, this is a vector length of 3, and this is a vector length of 91. And we can find the sum, that is 5005 for the third object. And we can find mean, and this will give the mean of each object. And if you want to find the maximum, for example, it will give maximum of all objects. So the lapply function is used for list, and you will get uh, again a list with different functions for it, but you will get the result for uh, each object in term of a list. So that is the function of lapply. So in next video we will discuss the sapply function and other more advanced apply functions. And these functions are most important to learn, as if you are working on different programmings, advanced type of programmings, and you want to create your own program instead of doing simple available functions in our, even though if you are applying Available functions, sometimes you need to manipulate your data, you need to transform your data, you need to uh, create different types of objects, different types, convert different type of objects into other type of objects. So you need to understand each and every apply functions in R. Thank you.